Hello, in this video I'll be explaining BFS, which stands for breadth first search. So, what is BFS? It's basically a graph traversal algorithm. Graph, yeah, I'll just write down graph traversal algorithm. Oops, move this algorithm. Right? So, and as the name states, it basically just walks through the graphs. It's basically like a for loop for a CS graph, right? Or just graph. So if you don't know what a CS graph is, it basically looks like this. It's not like a coordinate plane graph where there's an x-axis and the y-axis. It's just like it's just like sets of nodes, which are these circles, and sets of edges, which are these uh I guess line connecting the nodes. It's kind of like cities with roads in between them, right? So like city 1 has a road to city 2, city 3 has a road to city 2, and all that good stuff. And then I won't be explaining too much about graphs in this video, but the ba- uh the things you need to know are directed graphs and undirected graphs. So directed graphs, right? And then undirected graphs. So, well, what are they? In an undirected graph, there's no direction on for each of these roads. So like city 1 can go to city 2 using this road, and city 2 can go to city 1 using this road, right? So it goes both ways. It's like a two-way road, right? And then but in directed graph, a road can only go a certain way. So city 1 only can go to city 2, and city 2 cannot go to city 1 because, well, the direction doesn't match, right? But in this case, the example I'll be working with a undirected graph. But yeah, so BFS, uh, it's basically like a for loop to a graph, right? So just visits each of these nodes in a certain, I guess, a certain way. So here, this is how it works. So first, you start at a certain node. So let's start at node 1, right? Then what you do is you add all these adjacent nodes to a list. And when I say adjacent node, it basically means a node that's directly connected to, it's like an edge or like a node that's directly connected to the node we're considering in just a single path. So in this case, 2 is an adjacent node, right? But 5 isn't, because you have to go through multiple paths to get to 5. So 1 is adjacent to 2, 3 is adjacent to 2, 4 is adjacent to 5 and 2, and then 2 is adjacent to 1, 3, and 4, right? And yeah, so, and then we get each of these nodes and add it to a queue, or yeah, a queue. So if you don't know about a queue, it's just okay, we'll just work with a vector, right? So let's say we have a list, right? So like a list, right? And then, right, let's say we have a list, or, and when you're actually doing this, you would be using a queue, right? Okay, so we have a list. And then when we start with 1, we just add each of their adjacent things to the adjacent nodes to a list. So first, since we're starting with 1, we just want to add 1 to the list, right? And then now, what the algorithm does is that it visits the first one in the list. So basically, so right now 1 is only the only item in the list, so it visits 1, right? And then gets rid of 1. So now after visiting 1, there's nothing in it. But then while visiting 1, it adds its adjacent nodes to the list. So it gets rid of 1 and it adds 2 to the list, right? And now it goes, and then now again, it chooses the first value in the list and then visits it and gets rid of the value from the list. So it gets rid of 2, and now it adds the adjacent nodes the adjacent nodes into the list again. But and then we add what? 2 is adjacent to 1, 3, and 4, right? But when visiting 1, if we visit 1, we would add 2 again into the list, right? And it would just become a loop, I guess. So what we do is we have a list called visited, right? Visited list. And then let me make this smaller. We have a visited list. So there are 5 nodes in the thing, 5 nodes in the graph. So we have 5 elements in visited. 0, 0, 0, 1, 2, 3, 4, 5. Right? Let me fix this. Okay, so 5 elements in the thing, in the list, visited list. And when we visit a node, we mark the index of that list as 1. So we already visited 1, right? So first node in the list, and we mark it as 1. And then what we do with this list is that if we ever visit it again, we just don't do the other process where we add the other node. So like here, let's see. Here we get rid of 1. We've already visited 1, so we actually just don't add any of its adjacent node, sorry. And then we just continue on in the list. So now we visit 3. And let's mark 2 as 1 too, because we already visited 2, right? So now we visit 3. So get rid of 3 from the list and then mark 3 as visited, right? And then we add the adjacent nodes to the list again, 2, and then now we visit 4 since it's the first value in the list. All right, so we get 2 and 5 into the list, mark 4 as 1, and get rid of 4. Right, we have already visited 2, so we don't add any of its adjacent nodes. We just mark 2, and then we also get rid of 2 because we have already visited it. So now we have 5. We mark 5 as visited, and we get rid of 5, and we add any of its adjacent nodes, which is 4. And now on to 4. We have already visited 4, so we get rid of 4. And then this process goes until the list is empty. Okay, so that's basically how BFS goes. It's like, so yeah, I guess that's like the basic summary of the whole algorithm. And now I'll be showing you like I guess I don't know, just how to implement it with code. So yeah, here, let's get right into the code. So here, let's assume that we have a vector called adjacent with int n. So we won't do anything with like inputs and outputs in this code, right? Because we're just like, or actually, yeah, let's actually do that. So let's get int n, the number of nodes in the graph, and then also int m, which is the number of edges in the graph. And then again, number of nodes in the graph is just how many of these circles there are, and the number of edges is how many of these lines, right? The roads and the cities. So yeah, all right. So we take n and m, and then now we want to have like a adjacency list, right? Where we store the adjacent nodes of, I guess, a node. So let's have a list or a vector called adjacent, and we want to have n of those. So now we want to take in all the edges, And the way I'm formatting this, I guess like the inputs is very common where they have what? Here, let me just comment this out. Where they have N and M in the first line, just spaced out. And then the list of edges in like I don't know. So list of edges described as two numbers with an edge from 1 to 2, or like, you know, node 1 to node 2, right? Okay, so node 1 to node 2, node 3 to node 3, node 3 to what was it, node 2, and so on, right? But yeah, one thing to mention is that the way I'm doing this, the formatting of the inputs are very common in many problems where they have N and M spaced out, and in edges in a format that's two numbers spaced out, where the first number is node 1, and the second number is obviously node 2, and then that there is an edge between those nodes. And then they usually explain what kind of edges they are in the problem. So like let's in like a problem they will say I don't know, there are 5 cities with a road in between them and the road only goes one way, right? Like that would obviously be a directed edge, and if they say the road is two-way, then that's undirected edge, right? And then and yeah, so we'll be doing that. So int n b, whoops, right? A and B being A node 1 and B node being node 2, so that there's an edge between node 1 and node 2, right? And then we want to add adjacency A dot pushback B, and then all right. So this basically means that node B is adjacent to node A, and node B is adjacent to node A. And the reason why we have this line is that because it's an undirected edge, right? So if it wasn't directed edge, meaning that there's only a road between A and B, then we would get rid of this line. But since it's undirected edge, we just say adjacent of B is also adjacent of A, and adjacent of A is also adjacent of B, right? I hope that made sense, but yeah, okay. And now we have the adjacency list complete, right? So and then just like so with this problem, adjacency list would look like this. So value 1 would have list of 2, right? Actually, let me just do this with text. So get rid of that. All right, so 1 would have what? 2 in the list. Make this smaller, bigger. 1 would have 2 in the list. 2 would have 1, 3, and 4 in the list. 3 would have 2 in the list. And then 4 would have 2 and 5 in the list. And then 5 would have 4 in the list. Right? And yeah, okay, so that's how the adjacency list would look like. And then and the actual BFS. Okay, so earlier I used a vector as an example, but it's better to use a data structure called Q, because Q lets you grab on, I guess, get rid of the first element. So let's say we have a list of 1, 2, and 3, right? A Q would let me get rid of the first element, right, 1, and make the list 2 and 3 in a constant time, so 1 time. However, when we use a list, it would take O of n time to get rid of 1, get rid of the first element, because when you use a list, the list wants to I guess move the rest of the values and get rid of the first space. So like just scoot over the rest of the values, and that basically just takes O of n time. But with Q it lets you just do it in O of 1 time. So that's why we use a Q. And so first thing first, we want to insert 0, which is the first node. And I'll just say actually, yeah, I'll just say that node 1 is 0, node 2 is 1, and node 3 is 2, and so on, like node number minus 1, just for the sake of having like a list with a list that's 0 indexed rather than 1 indexed, which makes it way easier, right? And yeah, so here while q.empty. Oops. All right, so we want to take the first value in the q, so which is q dot front, and then now we want to get rid of the value q dot pop with q dot pop, and then now no, you know that visited list I mentioned earlier, we're gonna use that now. And so here, bool visited of n values, and then we want to first set all of the values to be 0, right, because they haven't been visited yet, right? And then so if we have already visited it, we just want to continue on with the loop. But if not, we want to mark visited a as 1. Okay, and then the whole so now we're gonna add its adjacent nodes into the list or queue. So for int I adjacent of a, q dot push, yeah, or I messed it up here, q dot push I, right? And then for the sake of just visuality, I guess we'll just print a, the node we're visiting, and then that's basically just BFS, and then yeah, so this is BFS, and let's make an input. Let's just make it this graph that we drew earlier. Okay, so all right, now we're gonna run the code to with the thing we drew earlier. So there are 5 nodes and 4 edges. 5 nodes and 4 edges. So the edges are 0 to 1. So 1 to 2, 1 to 3. Whoa. Oh my goodness, I'm sorry. I was running against the wrong file. My bad. So 0, 1, 1, 2, 1, 3, and then well, whoops, 3 to 4. Right, and then now it prints out the order in which we visit the cells, I guess, or the cities, the nodes, whatever you want to call it. So first we visited node 1, which is obvious since that's the first node, right? We put into the list, and node 2 afterwards, it goes here. Node 3, so boom, boom, and then node 4, so boom, boom, and then node 5, so boom, 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 right? And that's basically the, I guess, BFS, right? The BFS algorithm, which basically just traverses through the graph and, you know, uh, just walks through the cities and using the edges we have, right? Walks through the nodes with the edges we have, and yeah, that's basically the code. Bye bye.